Alrighty, guys, bear with my shaky hand here as I try to write and hold this camera here. What I'm going to do is I'm going to work out a series of problems that'll be similar to those that are going to be on your test on Tuesday. And I'll probably have to do this in a couple different videos just to separate it up so it's not too long. And I may make a mistake, which is why I probably will need to do a couple different retakes. But at any rate, for the following three problems, we are going to solve using the indicative strategy. So for number one, we're asked to use partitioning to multiply 132 times 7. When we partition based on place value. So we're going to take that 132 and break it down to 100 times 7, 30 times 7, and 2 times 7. So we're partitioning based on place value, and we get 700, 210, 14. And then we add these together. And we get a total of 924 for the product of that multiplication problem. Now for our second one, we're going to use compensation to multiply 29 times 50. With compensation, we generally go up an extra value till we get to a benchmark number or base 10 value so that we can do some easy mental math. So this 29 is awfully close to 30. So let's go ahead and do 30 times 50, which will give us 1,500. But we went ahead and multiplied an extra set of 50 in there. We didn't just do 29, we did 30. So we need to compensate by taking away 50. And our answer is 1,450. Okay, for 3, we're going to use an open array to multiply 62 by 22. With the open array, kind of looks like a Punnett square that you would have used maybe in biology when you're trying to find genetic output or whatever, if you took bio. What you do, though, you make this open array, and you, again, break this apart similar to how we did in partitioning by place value. So we take 62 and we break it down into 60 and 2. And we take 22 and we break it down to 20 and 2. And then you're basically doing 4 products. This is in many ways the distributive property. So we do 20 times 60, which will give us 1,200. We do 20 times 2, which will give us 40. We do 2 times 60, which will give us 120. We do 2 times 2, which is 4. So now you take your 4 different products, partial products, and we will go ahead and we will add them all together. I'm going to go ahead and do the 120 with the 4 there, just to simplify a bit. And then we add down. And our product is then 1,364. Okay, for the following problem, we want to solve using an area model. It says you have 4/9 of a pan of brownies left. If you give 1/4 of the leftover brownies to your sister, how much of a whole pan will your sister get? So let's illustrate 4/9. You can break this up in any way that you want. I'm thinking the way that I tend to cut brownies. I'll do them in rows, and then maybe rows of 3, and then I would break that up into another row of 3. But if you wanted to just do them in bars lengthwise, you could do that and do 9 of those. At any rate, I'm going to shade in 4/9. Okay, so I have 4/9 left over. I'm going to give 1/4 of these 4/9. What is 1/4 of 4 pieces? Well, it's just one little piece. This is how much I'm giving to my sister. Of the entire tray, that is just one of the 9 pieces. So that's the answer. This is a problem that doesn't require any additional partitioning, and this is one that you would want to start out with students because they get it. They can see it visually. No extra partitioning is needed, and so it makes the whole concept of a fraction very understandable. Okay, we're going to come over to our playground problem, which we did a few of these in class. We'll walk through it again. It says communities A and B are each building a playground on lots that are 50 yards by 100 yards. In Community A, they have been asked to convert 1/3 of their lot to a playground. 3/4 of that playground should be covered with blacktop, and the rest will be a grassy area. In Community B, they have been asked to convert 3/4 of their lot to a playground. 1/3 of the playground should be blacktop, and the rest will be a grassy area. In which playground is the grassy area bigger? In which playground is the blacktopped area bigger? Since the dimensions are the same, we can totally ignore those. What we're going to do is we're going to go ahead and depict each of these playgrounds and determine what portions are a playground, first off, because these are just lots that are divided into playground and then something extra. And after we determine the amount that's playground, in that playground we want to determine what portion is blacktop and what portion is grassy area. So let's go ahead and depict lot A first. They are converting 1/3 of this. So we're going to break it into thirds, pretend these are equal. This 1/3 is their playground. It's a very small part that they've been allowed to make a playground. Maybe they want to leave this future portion for further development, baseball fields, who knows. Lot B, the community has been given a more generous portion to make into a playground. They are asked to convert 3/4 of it to a playground. So we break into fourths. And so they definitely have a bigger playground. And maybe this small part over here will be tennis courts or something. Okay, now let's go back to Community A. They have their 1/3, that's a playground. Of that, 3/4 is to be covered with blacktop. So we depict 3/4 going the opposite direction. So we divide into fourths, 1, 2, 3, and 4. Now 3/4 of what is already shaded. So 1, 2, 3, just 3 of those 4 that are already shaded, that is what will be the blacktop. Meaning that 3 of all of the 12ths that are here are blacktop. And only one little sliver, this right here, this 1/12 is grass. Okay, oh, let me put the 12th there. Let's come over here. In Lot B, which has the bigger playground, we are told that 1/3 will be blacktop. So we'll go the opposite direction, breaking into thirds. Sorry, that is not even at all. But you're used to that by now with me. So 1/3 of that is going to be blacktop. So we broke it into thirds of those 3 sections that are already colored. Just 1/3 is going to be blacktop. Well, that is how many squares of the whole? Well, it's 3/12, just like the other one. 3/12 is blacktop. I'm going to abbreviate that BT. So A and B have the same amount of blacktopped area. The rest of this playground area will be a grassy area. Well, that's 6/12, or half of the area. So B has more grass. Okay, that is all of that problem. 6. Illustrate 5/3 divided by 1/4 with an area model. So the first thing we know we have to do is make these have a common denominator, because that's the only way that we can partition effectively is when we have equal denominators. So when we change this to 12ths, we'll change this top to 20 by multiplying by 4. And then this will become 3/12. So we have 20/12 divided by 3/12. We basically need to create area models that are out of 12 units. So we're going to have to draw 2 because we need to shade in 20/12. If you want to break that into a mixed number, that's totally fine. But we know we have to partition this into 12ths. And however you do that is just fine. Just be consistent. Okay, so we're going to shade in all of these. There's 12 out of 12. Now we got to shade in another 8 over here. Okay, so we have 20 12 shaded in. We're dividing this into sets of 3 12s, so we're counting by threes. So how many 3 12s can you fit into 20 12s? Well, here's one set of 3. Here's another set of 3. Third set of 3. Fourth set of 3. Now this one here, this will be 1, 2, 3 right here. These 3. Doesn't matter, as long as you count them up into thirds, doesn't matter how you count them. That's going to be a 5th set. And then let's go ahead and this one right here, that will be a 6th set. And you have 2 of those 3 12s left over. So you have 6 and 2 of the 3s that you counted, or 2/3 left over. I hope that makes sense and that you can see that okay. All right, I might be able to get this all into one video. The last one is the problem where sorry, my son is texting me a cute little picture of baby Danny, which I could show you here. How cute is that? Okay, back to math. All right, 7. Please use the standard bring down an explicit trade method to show how you would visually demonstrate to your students the connection between partitioning a dividend and the standard algorithm. What's a dividend? So just as a reminder, whatever number you're dividing by, so 543 divided by 4, that first number, that's your dividend. The second one is called your divisor. So we set up the standard method, 543 divided by 4. Over here, we're doing explicit trade shown visually with base 10 materials. That's just using the visual manipulative. So to depict 543, you're going to have 500s, which are our squares, 4 10 bars, 3 1s. What are these being partitioned into? To 4 groups. So what I'm going to do, I'm going to leave a little space, but I'm going to create 4 groups that I'm going to put these into. And we do a side by side of each of these. So we can number these as we go. Since I'm walking through by video, I don't necessarily need to number, but when you do it on the test, you could number and take your time with this. So we start out. How many of these 500s can I put into these 4 groups? Well, I can put 1 of each of those in. So I will put 100 into each of these 5 groups, and I record that over here. So that's step 1, okay? So I'm going to cross those out then, since I utilize those. And over here I do 1 times 4. I get a 4. A remainder of 100 left, and I see that right here. It matches up. Well, what do I do with that? I explicitly trade it now for 10 10s, and I bring that up here. So I'm explicitly trading. I'm going to draw a line just to keep these separated. I'm trading this up here for 10 10s, and that means altogether I'm going to have 14 10s. So I need to show that here, that I'm going to trade this for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 10s. So I can also then cross that guy out. All right. How many of these 14s can I place into those 4 groups evenly? Well, I can put 3 into each. So I'm going to record the 3 here, and I'm going to take 3 of these and place them into each, meaning I've placed 12 of them total. So I'm going to cross out 12 of them. I'm going to kind of do it in groups of 3. And I'll have 2 left over. So 3 times 4 is 12 with the 2 left over, and I need to make an explicit trade again. I'm going to trade this for 21s. I should have drawn a line here. I apologize. All right, so all together, I'm trading this for 21s. We already have 3 there, so that's 23. I need to actually trade these out and show that I'm trading those. So that's a lot of little dots. All right, but we have 20 of these little ones plus the 3. There's 23 total. How many times, or how many of these 23 ones can I place into my 4 groups evenly? I can place 5 into each of them evenly. So I'll go ahead and record that here. Okay, so I've gone ahead and I've placed all of those by putting 5 into each. 4 times 5 is 20. I subtract, I have 3 left over for a remainder of 3. So this is what this should look like visually. This is what it should look like as you're recording, bringing down and making the explicit trades in that standard algorithm. And remember, we do this before we then say, okay, guess what, students? You don't have to physically show these trades anymore. We can just bring down each one. But the good news is you've already scaffolded it by demonstrating it visually and making the trades here, and so they get it. But I hope that makes sense. If you have any questions as you're watching this video and you're working through the worksheet on your own, feel free to send me an email or stop by for office hours on Friday. God bless.